Welcome to Bethelmatics Academy. So today I want to take you through the inequality graphs. First of all, what is inequality? Inequality is a mathematical comparison that shows that two values or two quantities are not equal. That is, either one quantity or one value is greater than the other or less than the other. Or perhaps the two quantities are equal. So we use inequality to compare whether two quantities are equal or not. Before we go into the inequality graph, first of all, let us remind ourselves of the inequality symbols. Number one, we have this symbol. It is called less than. Number two, we have this symbol. It is called greater than. Number three, we have this symbol. It is called less than or equal to. And then number four, and it is called greater than or equal to. These are the four major symbols that we use in inequality. So now that we have reminded ourselves of these inequality symbols, now let's now go into inequality graphs. Now you must understand that each time we solve problems on inequality, we don't just have one value as a solution to that problem. Rather, we have a solution set as a solution to inequality. Every inequality problem has a solution as a solution set. So we use the inequality graphs to represent this solution set, either on a number line with an arrow or on a Cartesian plane. So in this lesson, I'm going to be focusing more on solving inequality problems and representing them on a number line. So let's take the first example. So in this case, we have nothing to solve. It's just for us to represent this solution set on a number line. So we proceed and draw a number line. Make sure that your number line ends with an arrow. And then because the variable name is x, we call our number line x. And then the next thing to do is to scale up your number line. But make sure that your scaling captures the number 3, because 3 is the boundary of our solution set. So let's call here 0. Let's call here 1, 2, minus 3. Once you have captured the boundary of the solution set on your scaling, you can add more 1 or 2 values in the front, more 1 or 2 values at the back. But there is no rule that says you must start from a particular number and end on a particular number. So the next thing is to indicate that x is less than 3. So it means we should go to 3 and draw a small circle, meaning that that place is actually our starting point. Okay, but this question says less than. So because the symbol here is less than, I'm not going to shade this circle. If the symbol here is less than or equal to, I'm going to shade the circle. I'm going to make the circle dark. I'm going to shade the circle this way. That the circle is shaded means the symbol is less than or equal to. But because it is just less than without equal to, this circle must not be shaded. So it means that the solution does not incorporate 3, but numbers before 3. Then since we are dealing with less than, of course, less than means numbers that are lower than 3. Our solution arrow will point this way. And you can stop anywhere. There is no rule that says that you must stop at a particular number, but you can stop anywhere. What's important is that you have shown us that the number starts from 3. Your arrow points this direction, showing us that the solution set incorporates all the numbers that are less than 3. This is a graph of x is less than 3. So let us also sketch the graph of question B. We proceed by sketching our number line. Since the variable name is x, we call our number line x. Since the solution set is for all the numbers greater than or equal to minus 4, our number line must capture minus 4. So we can call here 0, call here minus 1, then this is 1, 2, and then we can stop there. So next is to indicate the boundary of the solution. So the solution set says x is greater than or equal to minus 4. So we go to minus 4 and draw our circle. But because we are referring to greater than or equal to, we are going to shade the circle we just drew above minus 4. Now that we have shaded the circle above minus 4, now the solution set says numbers that are bigger than, that are greater than or equal to minus 4. We are going to proceed from here and then go this way, because numbers bigger than minus 4 are number that lies in the front of minus 4. Okay, so this is the solution set of x is greater than or equal to minus 4. And then we are through. Now let's look at question C. So in this case, we have s minus 5 on the left hand side and minus 7 on the right hand side. So we are going to solve this inequality first of all, so that we can easily tell what is the solution set. Mind you, inequality is not the same thing as an equation where we have equal sign. In inequality, we are usually careful when handling negative variables, because negative variables will definitely affect the inequality sign. So in this problem, we want x to stand alone, but there is a presence of minus 5 here. So to remove this minus 5, I'm going to add 5 to both sides of the equation. Adding 5 to both sides of the equation, I'm going to have it as x minus 5 plus 5 is less than or equal to minus 7 plus 5. So this means that x minus 5 plus 5 is 0, so it's gone. Is less than or equal to minus 7 plus 5. Minus 7 plus 5 will give us minus 2. That means for all the numbers that are from minus 2 downward are the solution set to this problem. Next, we draw our number line. So because the variable name is x, we call our number line x. Our interest here, the boundary here is minus 2. We must make sure that our number line captures the number minus 2. So let's call here 0, 1, 2, and the rest. Now, the boundary point is where? At minus 2. So draw the circle there. Because this is less than or equal to, I'm going to shade it. The meaning of this shading simply means that minus 2 is inclusive. Okay, so now numbers less than minus 2 are numbers in this direction. This is an inequality graph of x is less than or equal to minus 2. And we are true. So let's look at the next example. So in question D, we're asked to solve this problem and then sketch the graph. I want my x to stand alone, so the first step is to remove this 5. So this is plus 5. I'm going to subtract 5 from both sides of the equation. So we now have 15 so this becomes minus 5 here, minus 5 here. Okay, so 15 minus 5 will give us 10. Is greater than or equal to 5 minus 5 is gone, 0, and then this is minus 2x. Now I want x to stand alone, but I'm having minus 2x here. So what I'm going to do next is to divide both sides by minus 2. Now, in inequality, inequality is not like the ordinary equation, the normal equation you know. In inequality, when you multiply both sides of an equation by negative number, you must change the sign of the inequality. And if you divide both sides of inequality by a negative number, you must also change the sign of the inequality. That is the difference between inequality problems and equation problems. So because this is minus 2, and I want to divide both sides by minus 2, so I'm going to now rewrite it as 10 is less than or equal to minus 2x, because I'm going to divide both sides by minus 2, divide both sides by minus 2. So that minus 2, we cancel out minus 2, and then we are left with 10 divided by minus 2 will give us minus 5 is less than or equal to x. Now, many students used to make mistake when plotting a graph of inequality that is looking like this. This solution set simply means minus 5 is less than or equal to x. That is to say, if minus 5 is less than or equal to x, it means that x is greater than or equal to minus 5. So, in order not to make a mistake, you can write this as x is greater than or equal to minus 5. That is what it means. Because here I say that minus 5 is smaller or equal to x. It simply means that x is bigger or equal to minus 5. So I have rewritten it in this form. I can now easily sketch the inequality graph. So this is x. Okay, so since the boundary point is minus 5, just make sure that your number line captures minus 5. So we can start from here. This is 0, 1, 2. So since we are dealing with minus 5, it means that the boundary point is at where? Minus 5. So above minus 5, we make our circle. Since it is greater than or equal to, we are going to shade the circle. And then numbers that are greater than, numbers that are bigger than minus 5 are definitely numbers this direction, numbers in your right hand side. So our arrow will point towards the right hand, and it can stop anywhere. So this is a graph of x is greater than or equal to minus 5. Okay, so in this question, we have two inequality in one equation. So this is a case of compound inequality. To solve this problem, at this center, I want x to be alone. So the first thing to do, since this is minus 6, we are going to add 6 all through to both sides of the equation. So this becomes minus 4 plus 6 is less than or equal to 2x minus 6 plus 6 is less than 8 plus 6. So we have successfully added 6 all through. So here, minus 4 plus 6 will give us 2, which is less than or equal to, here, minus 6 plus 6 is gone. So we just have 2x. So this is less than 8 plus 6. This will give us 14. X is not still alone. It's still having a coefficient of 2. So the next thing to do is to divide all through by 2. So this becomes 2 is less than 2x less than 14. Divide here by 2. Divide here by 2. Divide here by 2. So 2 divided by 2 is 1, which is less than or equal to, here 2 cannot cancel 2 and have x. This is less than 14 divided by 2, 7. So it simply means that the solution to this problem is an interval from 1 with 1 inclusive to 7 with 7 excluded. There's another way you can solve this exact type of interval inequality. I'm going to demonstrate that second method when solving question number F. So let's now plot our inequality graph. So we sketch our number line. We must make sure that our inequality graph captures 1 and 7 because these numbers are our boundary points. So this is 0, 1, 8, I call here minus 1, minus 2. Okay, so the first boundary point is at 1. So this is 1. So above the 1, I indicate my circle. But because this is less than or equal to, I will shade the 0 that I've written above 1. Then the next boundary point is at 7. So this is 7. I'll draw a circle above 7 because this is just less than and not less than or equal to. I'm not going to shade the circle. So see, the solution set means numbers between 1 and 7. That's what it means. Numbers between 1 and 7 with 1 inclusive and 7 exclusive. So it's for us to come this way and meet, and that is your final answer. So question F. I'm going to be using the second method I told you about to solve question number F. In this second method, I'm going to split this question into 2 different questions. A, I will have it as 1 is less than 5 minus x. So I'm going to solve this first of all. Because I want x to stand alone, I will subtract 5 from both sides. So this becomes 1 minus 5 is less than 5 minus 5 minus x. So what I did was subtracting 5 from both sides. So 1 minus 5 will give us minus 4. This is less than 5 minus 5 is 0, and we are left with minus x. So in the end, we are going to divide both sides by minus 1. Once you divide with a negative number, the inequality sign must change. So this becomes minus 4 is now greater than minus s because I'm not dividing by minus 1, minus 1. So minus 1 will cancel minus, so that minus will cancel minus, of course, so that 4 is greater than x. 4 is greater than x means that x is smaller than 4. That's what it means. If they say 4 is bigger than x, it means that x is smaller than 4. So I have interpreted it this way for easy sketching. Then the second part is solving this part and this part. This is 5 minus x is less than or equal to 4. So I want x to stand alone. I'm going to subtract 5 from both sides. So this becomes 5 minus 5 minus x is less than or equal to 4 minus 5. 5 minus 5 is 0. So that we have minus x is less than or equal to 4 minus 5 will give us minus 1. Remember, once we divide with negative number, the inequality sign will change. So this becomes minus x is greater than or equal to minus 1 because I'm not dividing by minus 1, minus 1. So this means that minus will cancel minus, so that x is greater than or equal to minus 1 divided by minus 1. Minus will cancel minus, so that we'll have it to be 1. So it means that our solution, x is less than 4, and the second one to be x is greater than or equal to 1. So next thing is to draw the number line. So I will sketch my graph. So make sure that your number line captures 4 and 1. So this is 0 plus 1 minus 2. Okay, so x is less than 4 means numbers that are less than 4. So we make our circle above 4. Numbers less than 4. Remember, we're not going to shade it because this is just less than without equality. So numbers less than 4 are numbers this way. For s is greater than or equal to 1 means numbers that are bigger than 1. So we start from 1. So since it is greater than or equal to, we shade the 1. So numbers bigger than 1 are numbers this way. So by so doing, the two inequalities have joined. So that means I can conclude by writing this as an interval. I'll write 1 here, put s at the center, put 4 here. S is less than 4 is this part. S is greater than or equal to 1 means that 1 is less than or equal to x. So I can now put less than or equal to. That is the interpretation of this part. If you have learned something in this lesson, do well to leave a comment for me in the comment section below. If you have a question, also feel free to ask me in the comment section below. Thank you so much for watching. See you in my next video.